Okay, let's say we started studying this crazy expensive liquor called Karuzawa Aqua of Life, and we were able to study it systematically in a lab. And because of its high alcohol content, 50 to 60%, I don't think we'd be at all surprised to find the causal relationship between regularly drinking this liquor and an increased risk of liver cancer. And just to be clear, when we say causes, it doesn't mean that every single person who drinks this will get liver cancer. What it means is by drinking this, on average, we increase the risk of liver cancer, maybe by a little bit, maybe a lot, but I think this is a well-documented causal relationship already. And liver cancer causes earlier death. Again, maybe not with every person, but what happens is, all else being equal, having liver cancer versus not having liver cancer increases your risk of an earlier death. So these are two causal relationships. Regularly drinking high alcohol content liquor increases the risk of liver cancer. This isn't just a correlation, this is an actual cause that's been established. Liver cancer causes an early death. So say you have two groups of people in the world, people who uh, drink this Karuizawa Aqua of Life liquor, and people who don't. I mean, I think the vast majority of the population would fall into this category. At $60,000 a bottle, that's a pretty expensive liquor, and there's a reason why I chose that. So what would we expect? We've already said that we're going to go ahead and assume that there's a causal link between this liquor and liver cancer, and we know the causal link between liver cancer and death. So if that's true, if those causal relationships are true, if we looked at the people in the world and took the average lifespan of all the people who drink this liquor and people who don't drink this liquor, we would expect to see that these people are dying a little earlier, right? Well, that's not true. And in fact, this wasn't an actual study. I'm making some guesses here, but I think if you studied it, you'd find something like this. I think most people in the world don't drink this liquor, and the average lifespan around the world right now is around 71 years. The people here, and this is why I chose such an expensive bottle of liquor, the people who are drinking this liquor here are extremely wealthy, for the most part, are extremely wealthy people. Maybe there are some locals also who drink this. As it turns out, Japan has an extremely high average lifespan anyway, so whether it's local Japanese farmers or whether it's the people who actually drink this, in any case, we're looking at people who just tend to, not because of drinking this, but for other factors. I mean, wealth adds on a lot of years to your life. The best predictions right now are about 10 years for a female, 15 years for a male, between the very wealthy and the very poor. Just because of all the things, again, that might not be causation. That may be correlation with education, with the foods that are eaten, with all kinds of variety of factors. But the truth of the matter is, the people who drink this are not the same as the people who do not drink this. There's a difference between the two groups of people. So even though this liquor may be slowly killing them, may be increasing their risk of liver cancer, they have all these other odds in their favor, which is actually raising their average lifespan. So this is a tricky part about a causal relationship. Even though the liquor itself may be causing a decreased lifespan, the people in general who do drink this liquor, who just happen to drink this liquor, it's very possible that they are living on average longer than these people, just because the people who drink this liquor are different than the people who don't drink that. This is lurking variable. This is a great example of a lurking variable. Wealth here is a lurking variable. So one thing we can say, if that's confusing, um, is that if we take any given person, say this is Jimmy, and let's say Jimmy is wealthy enough to make the decision to regularly drink this liquor throughout his life, or to not drink this liquor throughout his life. So all else being equal, if Jimmy chooses to drink this liquor, he will have a shorter predicted life. If he chooses not to drink this liquor, longer predicted life, all else being equal. So nothing changing about his wealth status or his social circles. Some things that may actually be linked to this, but the point here is instead of saying an average lifespan of 79 years, it's very possible that these very wealthy people could have had an average lifespan of, say, 80 years or 79 and a half years or something a little bit higher on average if they hadn't been drinking this. So the cause will lower anyone's, if there is a causal relationship, it'll lower anyone's risk. But what we can't do is we can't just look at the people in one group and compare them to the people in the other group if the two groups of people are totally different. So how do we get around that? How do we get past this causal issue? We randomly assign the people to the two groups. So if we randomly assign, say we have 100 people in our study, randomly assign 50 people to, good luck getting funding for this by the NIH, but if you could, 50 people to drink this throughout their life regularly and 50 people to not add this on top of their normal drinking habits already, probably what we'd find is that this group then has a higher average lifespan, because there we're balancing out all these lurking variables between the two groups. But if we just look at the people who are already drinking this on a regular basis and who are not already drinking this on a regular basis, we're going to see very different groups of people that we can't be sure whether it's the alcohol itself or any number of these different factors, these lurking variables between the two groups, that's actually impacting that lifespan.